Hey guys, welcome back to the video. So in today's series we are going to be talking about bones and joints. So in today's particular video we will be talking about, so first of all, the composition, types, and some other definitions. Okay, and then these can be split into hyaline, you've got cartilage and dense fibrous connective tissues. Cartilage can be split into hyaline and fibrocartilage, fibro, and the FCT can be split into ligaments, tendons, and capsules, and we can expand on ligaments as well. And for types, you've got three types: fibrous, cartilaginous, and synovial. And synovial will have 6 different types, which we'll be going into detail in the next video, along with bone growth in general. So let's just talk about joints first of all, and first of all talk about hyaline and fibrocartilage. So the difference between them is that hyaline, there's more, so it's composed of, you've got these legs, right? Just give me a moment. You've got these legs, are called lacunae, where you have chondrocytes in them. So this would be the ECM. Actually, I'll just label them. So ECM. These will be the lacunae, which contains chondrocytes. So these are the stem ligament cells, chondrocytes, lacunae. And we've also got ECM. These are the main thing as well. And this black dot right here is just the nucleus of it. So for hyaline, if you look through a microscope, its structure would be more translucent compared to fibro, because hyaline ECM has more water, more H2O, less collagen. And for this guy, you can see this band of stripes of collagen here in one direction. So unidirectional, less H2O, more collagen, just like that, and they go along this way, so it's unidirectional. So because of the different composition, therefore they will have different functions. So hyaline is for resisting in compression, right, and this guy over here is resisting tension. So they can both perform, hyaline can both resist compression and tension, but it's more likely to be used for compression because of higher water concentration in the ECM, extracellular matrix. So the cartilage can't be squished or compressed, while for fibro or fibrocartilage, it can also resist compression because water is still present. But because there's more collagen, its main function will be just resisting tension. And therefore, because of that, you can find them in different positions, for example. And so for example, between bones, you can find them a lot between bones. So this layer over here is going to be your hyaline cartilage. Another name is called articular cartilage. There you go. Fibrocartilage can be also found, but they're not like in between, but kind of like on the side, like this. So here you go. This would be fibrocartilage on the side over here, and they help with resisting tension, so prevent the balls from moving away too much. And it also help with so they both help with frictionless movement but this guy is more about resisting compression. This guy is more about resisting tension or being pulled away, or when force pressure is being exerted in this direction, whereas these guys are being exerted in this direction. All right, just like that, for example. So different forces, direction, so they are fitted for different purposes and they're found in different positions, right? So those are this is how you'd look at it under a microscope. So these two, this is for fibro, this one's for hyaline, and these are their positions where they're found between bones. And fibrocartilage can also be used to increase surface area or increase between the bones where they're in contact, so more stability overall. Right, now let's move on to DFCT, dense fibrous connective tissue. So you've got ligaments, tendons, and capsules. I'll probably draw them down here because it's we don't have enough space. Yeah. So let's plot a little. Actually, we'll do it up here at the top left. So ligaments and tendons, and you've also got capsules, right? But the main thing we're comparing right now is ligaments and tendons. So ligaments, they connect bone to bone, while tendons connect muscle to bone. Right, capsule is just, you can find between bone to bone as well. But these guys have a more similar structure with lots of collagen, right? So, of course, ligaments have collagen and elastin, plus elastin, same as tendons. Right, but for tendons, there is more collagen and less elastin. For ligaments, they're basically the same. So we'll compare the amount of collagen and elastin versus ligaments. So I'd say this guy's more and less, right? Just like that. And so the different functions, but collagen is to resist, as I said earlier, tension, and elastin is to resist stretch and help with recoiling of, when bones are moved or muscles are contracted, then you want elastin to move them back into its original position. Right, so ligaments are mainly used for stabilizing bone structure. All right, so help with stabilizing the skeletons. And tendons are basically for muscles contractions. Right, and ligaments are going to also be used for movement as well. But its main function is to stabilize bones and the skeleton. And so those are, we've clarified the differences between them. Capsule is quite different actually because it's made up of a lot of more different things, and I think it's better when we actually explain synovial joints as well, so the different types of joints. So I can draw like what a capsule look like. So imagine this, right? You've got your bones, your upper one, and you've got your lower one. Right, you can find some cartilage between them. And then you've got, so this is your periosteum layer outside here, just running along like this. Right, and then you connect here. And you connect here, perfect, just like that. And this right here is the capsular ligament. And you've got something else. So the outermost layer is not the capsule itself, but the ligament, right? So as I said earlier, it connects bone to bone. So this would be called capsular ligaments, just like that. Just zoom in for you guys. Capsular ligament. And inside here will be your synovial membrane. Right, so this is the start of the actual capsule. And you've got the hyaline cartilage. As I said, this is the periosteum. Fuses with your cartilage. Sorry, your ligaments. Right. And then, so the synovial membrane kind of lines the inside of the capsule while the ligament is the outside, and then synovial membrane secretes. So this is the synovial cavity, right? And the synovial cavity, or the joint cavity, contains synovial fluid secreted by the synovial membrane, which helps a lot with movement, because you want frictionless movement, you want smooth, so that the fluid helps a lot with that. And this entire thing is called a capsule, or a joint capsule, or an articular capsule, mainly because you can find the hyaline or the articular cartilage inside this capsule, basically here. Right. Now we will move on to types of joints. Right. Let's first define these. So joint loading is when you're moving because your cartilage is avascular, so the tissues don't have any blood supply to them. It's really hard for nutrients to get into every single cell, because it's quite big and diffusion is not quite enough. So when you move around, actually, that pressure, or the fluid or the nutrients is being pushed into the ECM of the cartilage, and it helps maintain and helps grow and stuff like that. So when you damage your cartilage, it's really hard to repair because, again, there's not a lot of nutrient supply because it's avascular. Right. Bony congruence is the total amount of points of contact between bones. So for example, this bone right here, if I drew this, right, if they were touching each other, which they're not in this case, right, you count the total number of points of contacts, and the higher so the more number of points of contact, so the higher bony congruence, the more stable that joint is, right? So joint is, or an articular, is where bones meet, and the higher number means that it's more stable, basically, because the bones are keeping each other from moving around because of friction and also of physical hindrance, right? And range of movement refers to basically like how joint determines the movement, right? Because there are different types of joints, and those different types of joints are made up of different things, or in different amounts of each one of the components, so that it produces a different result on movement. So you have joints where there's not a lot of movements because it's really stable. You have joints where it's you can move around a lot because there's not a lot of stuff to hold the joint or make it more stable. And ultimately, range of movement is determined by the structure of joint. So the shape of the bone where the joint is, so where they meet. Also all the tissues that DFCT involve, like ligaments or tendons or capsules, and the body surface contact as well. So those are the three things that determine the movement of a joint, right? So which is basically the structure of the joint. Now we'll move on to the types of joints. So we've got fibrous, fibrous is when you want it to be as stable as possible, so the joint as stable as possible. You don't want movement because and you want it to be stable basically. So the tissue, I'll actually write a table down to compare. Fibrous, sorry, fibrous, cartilaginous, and synovial, right? So this guy, least and most amount of movement possible. So an example would be your skull sutures, right? So when your skull is still developing, they grow towards each other, and where they meet are called sutures, and they have ligaments in them. So tissue would be you'd have ligaments between them to hold the bones together. Limit to function is to limit stability. Limit movement and provide stability. That cartilaginous is a bit of in between, right? Because synovial is the most mobile one after all. So, but yeah, you have to know the example. So, an example of it will be skull sutures and the distal. So let me just try and write distal tibia fibula joint. So I have two examples ready just in case. Distal tibio-fibular joint is basically near where your ankle is, or around that place over there. Even though your ankle is really mobile, like you can rotate it, perform circumduction. But the distal tibio-fibular joint is an example of a fibrous joint because it limits movements and provides stability. Cartilaginous is when you have cartilage. So fibrocartilage instead of ligaments. So this guy is less hard, but still have collagen, right? So ligaments, of course, have the most collagen. Then fibrocartilage has less collagen, basically. So function is some movement. An example would be your vertebral column, or your intervertebral disc between them. Right, so between your nodes, each one of your nodes, or each one of your vertebrae, and you also have the pubic symphysis, which is like the bone in your hip, so like that joint in your hip bone, basically. It's like, let me try and draw it out. It's kind of like, imagine this is your hip. So I know the drawing's a bit hard to visualize, but bear with me. I'm trying out like a rough sketch of what it'd look like. And no, it's not the best, but oh gosh, it's really horrible. Alright, so this is what it looked like over here. This is your hip bone. You've got your ilium, ischium, and pubis around here, and then this is your pubic symphysis. So that's your hip bone. This is the outlet where, in a woman, this is where your womb is and where you can hold and deliver the baby. Right. And then now we will move on to synovial. So of course, synovial is the most, so a lot of movement. It's the most loose, I'd say. An example would be your knee, right? The composition is articular cartilage. You do have a little bit of ligaments and stuff in there, but mainly articular ligaments. And this is when it's split up into different types again. So you've got 6 types here: pivot, ellipsoidal, condyloid, plane, saddle, hinge, with bowl and socket. So let's just get right into it. Oh, also, my bad, I forgot to draw you guys the structure of your knee. Right, so it's kind of like this. Let me again give it a shot. I know it's not as good, but bear with me here. I'm trying to like draw it so that it would look good. Basically, you've got this bone in the middle here. I don't know why it's here. Just like that. This area over here is kind of like, this would be your cartilage. Oops, my bad. Here you go. So this is your knee, basically. And I know I'm missing out the joint capsule, but I'm just trying to show you the different types of ligaments involved, right? So this is your tibia, as you guys know. This is your femur, and this is your fibula. Oh shoot, fibula, right? This is your posterior, anterior cruciate ligament, or ACL, which a lot of athletes have torn. Posterior cruciate ligament. I'm not going to complete it. Right, here you've got your medial collateral ligament, and here you've got your lateral collateral ligament. Right, so those are the 4 main types of ligaments I'd say you have to learn. This, and you've got this as well, so you see your meniscus or menisci. So this is your medial meniscus, and here is your lateral meniscus. Right, and ACL connects, so I'm trying to draw like a table. So ACL, PCL, MCL, and LCL. So a table of some sort for this. Now, ACL connects the front of the tibia, to the back of femur, or the anterior of tibia and the posterior of the femur. PCL is the other way around, vice versa. And medial collateral ligament connects the femur to the tibia. F to T, lateral collateral ligament connects the femur to the fibula. Alright, that's how it is. And yeah, this one's more lateral, of course, so that's why they call it laterally, medially. Yep. And ACL connects, so since it's like that, it's preventing flexion. Oh, wait, hold on. Yeah, it's preventing flexion. ACL is preventing. Kind of right, like if you imagine if you curl up your leg. Nah, probably not. I'm just yapping too much. So your ACL, these guys are called intracapsular ligament, and these guys are just capsular, because these guys are around it and these guys are inside the ligament, right? And if you think about it, the ACL, since it's connecting to the front to the back, like I'm trying to draw it now for you, this is the side view, okay? So imagine this really bad drawing, a side view. If you have your, so this is femur, tibia, right? If it's prevents stretching, right, or tension. So it prevents the displacement of the tibia, so anterior displacement of tibia, or posterior displacement of the fibula. So anterior is this way, posterior is this way. So this prevents any one of these. Same for this guy, prevents anterior displacement, actually vice versa. Anterior displacement of fibula and posterior displacement of the tibia. That's how they prevent it, right? And for your capsula, which is right, tibia, femur, it's a tibia, my bad. There you go. Medial collateral ligament prevents, so imagine this is your knee, this is your midline, this is the outer. If you're stretching this way, that's abduction, so prevents abduction. MCL prevents abduction. The other guy, LCL, prevents adduction. That's how it is. And in the next video, we're going to be covering the different types of synovial joints and also bone growth.